Welcome to another video on circles. So this is the last bit on the circles chapter. This is chapter 6. So for circles, you need to remember some of the circle theorem from GCSE. And there's a whole section on circle theorem on GCSE. And one of the things you need to know is about constructions as well. So if we have, if you remember the bisector of a triangle, you could see to work out the perpendicular bisector, you would get something like this. And if you did it for the other side, perpendicular bisector, you get this line here. And finally, for this line from GCSE, if you're on a perpendicular bisector, you get the following. So what we see then is, if you were to draw a circle around it, where the three lines intersect, that will be the center of the circle, which is quite interesting, right?
Oh yeah.
So now, if we have a circle and we have two chords like this, and we were to draw a perpendicular bisector, it's quite interesting because if you look at the point of intersection, that would be the center of the circle.
Yeah.
So for any triangle can have a circle drawn through the corners. So because each side is a chord of the circle. So if one side of the triangle is the diameter, the angle of the semicircle is 90 degrees. Okay, so we take an example. So we're told the point A, B, and C lie on the circumference of the circle, and we have to show that AB is the diameter of the circle. So with the circle chapter, I always advise my students to always draw out the circles. You don't need to draw the axis, but draw it to visually see what's going on. So we want to find the equation of the circle. So if AB is the diameter of the circle, then the hypotenuse, you should have a hypotenuse in a right angle triangle. So if we use Pythagoras theorem and we look at the difference in the x value, square it, plus the difference in the y value, square it. So the distance of A to C would simply be root 80.
Yeah.
And that goes to previous chapter on straight lines, where you would have learned how to work out the length of a line and so on. Now, same way, we're going to work out the length of BC. So it gives us root 80. And we'll work out the length AB. So that's square root of 160. So if we substitute this into the Pythagoras theorem formula, a squared plus b squared equal to c squared, we see is actually a whole. 80 plus 80 equal to 160. So that means the length AB comes from a right angle triangle. So if the angle ACB is 90 degrees, then AB must be the diameter of that circle. Because from the circle theorem, we know angle at the circumference, if it's 90 degrees, then it must go to the diameter. So we say angle in a semicircle is 90 degrees using that circle theorem. So to find equation of the circle, we need to know the center of the circle. And center of the circle is just going to be the midpoint between A and B. Now we've seen this on the previous lesson. So what I'd like you to do is pause the video and work out the center of the circle. So the midpoint of AB, you simply add the x coordinate divided by 2, the y coordinates, add them up, divided by 2. So that gives us the midpoint of -2 and 3. So that is our center of the circle. And since we already know the diameter, the length of the diameter, we simply just half it to get the radius. So root 160 divided by 2 is our radius. Now we've got everything we need for the equation of circle. We've got the midpoint and we've got the radius. So that means the equation of the circle, again, if we recall from previous lesson, this is the formula for equation of circle. If we substitute in the a and b and the r values and tidy up, here we have it. This is the equation of the circle. Alright, let's take another example. So we're told these points P, Q, and R lie on the circumference of a circle. The equation of the perpendicular bisector of PQ is given as y equal to 2x. And we're asked to find the equation of the perpendicular bisector PR and find the coordinates of center of the circle. And also to work out the equation of the circle. The first thing we want to do here is draw a sketch. So as I said before, don't worry about the axes. So if we draw the circle, we know all 3 points lie on the circumference of the circle, and we are given the perpendicular bisector, the line of the perpendicular bisector between P and Q. So once we draw this, it kind of makes it easier for us to see what's going on. So what we're going to do is connect P and R and find the perpendicular bisector of that. So once we've worked out the midpoint of PR by substituting into this formula, so we got the midpoint minus 211. Now what we need to do is work out the gradient of PR, so the difference in y over difference in x, so that gives us the gradient of PR, which is 1. So the gradient of the perpendicular line, because they're perpendicular, they have to multiply to give you -1. So the gradient of that line is -1. So now you've got the point the line is going through and the gradient of that line. If we just substitute into the equation of the line y minus y1 equal to mx minus x1. Okay, and that should give us the equation of the line as y equal to minus x plus 9. So there we have it. That's the answer to part A. We've got the equation of the perpendicular bisector of PR. Now, this will help us with part B, where it says find the coordinates of center of the circle. So because we have two lines intersecting, where they intersect, we said in the previous slides, is the point center of the circle. So we could just simply use simultaneous equation, substitute one into the other, and we could work out the values of x and then subsequently the value of y. So once we work this out, we get the x value as 3, and if you substitute x equal to 3 into any one of this equation, that gives the y value of 6. So the center of the circle would be the coordinate 3, 6. Now we have the center of the circle. We could work out the radius. So what you have to do is just pick 2 points from the center. So you could either choose P, Q, or R, because they all have the same radius. So using this distance between 2 points, I could work out the radius, which is 10. So now we've got the radius, we've got the center of the circle. We could just simply substitute into this equation of a circle, and that will give us the equation x minus 2 all squared plus y minus 6 all squared equal to 100. So that is the equation of the circle. And that's it. That's the equation of the circle chapter all complete. So the whole point of drawing the circle is to help you visualize. So in this chapter, I can't emphasize enough that you should always draw the circle just to see what's going on. So this is the end of this chapter. So you could just have a go at mixed exercise or do some exam questions on the circle equation. Until then, stay safe. Bye.